Because you know I'm all about that bass, no.
Hello, we're Group P, and our names are Summer Galentine,
Claire Lyon, Nina Sanfar, and Kelsey Vandia.
Every inch of you is perfect from the bottom to the top.
Design A included a vertical base and a T-shaped arm. One notable attribute of this design was the two trapezoids attached to each side. These trapezoids contributed to a centered body and evenly distributed weight. A drawback to this design is the hindrance of momentum due to its vertical orientation.
Design B included a pointed aerodynamic front, T-shaped base, and a single motor. These attributes combined to provide overall symmetry of the design. Drawbacks for this design involved uneven weight distribution due to the Arduino placement.
Design D was based on the overall shape of a rocket ship. Positive attributes of this design included a sleek 3D printed shield over the AEV and a rectangular base to make the vehicle aerodynamic. The main drawback of this design was the overall weight distribution.
Design C also utilized a T-shaped piece as the body of the AEV. It also included two propellers facing in opposite directions in hopes of having equal energy consumption for forward and backward motion. Another feature of the design was a 3D printed cap in order to make the vehicle more aerodynamic. This 3D cap is a variable aspect to the AEV and therefore was a drawback. During Lab 6, the overall design of the AEV was altered by flipping the orientation of the wings on the AEV upside down. This greatly affected the overall performance of the AEV by slowing it down as compared to the sample AEV.
In Lab 7, the wings were reversed back to their upright position and the battery was attached to the arm of the AEV. This greatly improved the performance of the AEV and allowed for less space to be used on the base of the model.
Within the PDR, the design mentioned from Lab 7 as well as a vertically oriented design resembling Design A from the introductory designs were compared in order to determine which would be the final design. Overall, it was concluded that the horizontally oriented design would make a better AEV because of the higher overall efficiency of the vehicle.
I believe I can fly. I believe I can touch the sky. I think about it every night and day. Spread my wings and fly away. I believe I can soar. I see me running through
No trouble, I'm all about that bass,
The final design features a combination of certain qualities from AEV designs previously tested in labs. The AEV design proved to be most aerodynamic with the base of the AEV being oriented perpendicular to the ground and the wings positioned in a horizontal fashion. In utilizing the arm of the AEV as a space to put the battery, the overall design proved to be very sleek and functional. In the testing stages of the final AEV design, problems arose with the sensors of the AEV. However, the model itself proved to work exceptionally well once the sensors were replaced. The group decided to use a position-based code in order to complete the stated task. This proved useful by providing a reliable code that, once perfected, had little to no problems. In looking back on this project as a whole, the group overcame a lot of difficult obstacles. Given that there were a multitude of base design changes as well as battery placement changes, the balance that could be seen within the design is a celebratory aspect. Within the testing itself, machine malfunctions set the group back often. Whether the sensors weren't working correctly or the wires were no longer connected, the time constraint within the labs always proved to be a challenge. In all, the AEV project highlighted the creative thinking and design analysis necessary in completing the working design process.
I can fly. See, I was on the verge of breaking down.